Okay, we are looking at what points this function is continuous. Now, we've learned how to do this algebraically about by hand, but we can also do this on our graphing calculator. One of the best ways to look at continuity is simply to look at the graph, and the graphing calculator allows us to quickly produce that graph because the most basic definition of continuity is if you are tracing the graph with your pencil, whenever you pick up the pencil, that's a continuity break. And so obviously by graphing it, we can clearly see where those continuity breaks are, where those asymptotes exist. And this is also a great way to look at limit because we can see with that asymptote how the limit's approaching but never quite getting there. So I really like the visual version of both continuity and limits because it really helps us to see what's happening and gives us a picture in our head as we're doing the algebra later and the more in-depth calc work. Okay, so I'm going to start by graphing this. So I'm going to go y, and I'm going to put this in. I always put these in top and bottom in parentheses, so in that way I make sure that it does it in the right order. X squared minus 12x plus 35. Okay, and then I'm going to go to graph. Something I did before I was messing around with this is I have changed the window on this. You can see I went by 2's and I've got it here at -15, just mainly because when I first put it up there, when I was setting this up, I noticed that it was kind of large. So when this first comes up, if you're like, I'm not seeing it. For instance, when I first saw this, I wasn't seeing the middle part of this graph, the bottom, that parabola down there at the bottom, because my screen wasn't big enough. You will often have to adjust your windows. You can try the zoom in, zoom out, or a lot of times I just find it easier to click on windows and change to what I want. Now we need to know what these asymptotes are. There's a couple of things. You can hit trace and just start going along, and as you go along the x's, all of a sudden it's going to skip from one graph to the other. It skipped 5. That's my asymptote, so I know I'm going to skip 5 and then just keep going. It's going to do it again. The thing you can do is if I go to second table here, this is the XY table. Remember when you first learned to graph, you made a little XY chart, you plugged in points? This is this list, and you can do whatever you want here, but you'll notice it has an error here at 5 and 7. Those are our asymptotes. So you can see that either way, it's going to clearly show you where those asymptotes are. So when I come over here, I'm starting at -infinity. Oh, okay. Open on interval notation, always an open for infinity, and we're going to go to 5, open because we're skipping 5. We don't want to include it, so we use the parenthesis, so we're skipping it, or, and then we're going to go from 5 to 7, or we're going to go from 7 up to positive infinity. You would use a bracket, remember, if you were going to include it, but we're not going to include it. These are the numbers we're skipping. This really just says it's everything but 5 and 7. You always use a parenthesis to show it doesn't include it, and you always use a parenthesis on infinity. And then this or just shows the connection here. So check answer. And so that's how we can use our graphing calculator to quickly see continuity.